Hey everybody, this is Patrick GMT, and this is going to be the first video in what I hope to be a more comprehensive pre-algebra course. So we'll start off talking about how we kind of we're moving away. We're doing this generalization. We're moving away from arithmetic to a more general system. And this generality, which we call algebra, that's what gives it its power. It just has more flexibility, and we can apply it to more situations in a more easy manner. And if you have trouble with arithmetic, some of the algebra is going to be maybe sometimes a little hard to follow. So I always even tell people, if you're getting stuck on the algebra, try to do whatever the procedure is with numbers. And that way it'll give you something more tangible to think about. Because again, we are going to be dealing with letters and just more generality. So let's get started here. We're just going to talk about a little bit of terminology. And again, as the course progresses, we'll get into certainly some more advanced topics. But the first couple of videos, there really won't be a ton going on. Again, just some terminology and just pointing out some notation and some different ideas that we'll start working with as we proceed. Okay, so what we're going to do here in this first part is we're just going to talk about representing addition, subtraction, multiplication, and division using the symbols of algebra. And then we're also going to talk about identifying what are called algebraic expressions. So kind of what we're doing here is we're just learning a little bit of notation, and we're trying to make this transition from, we want to be able to take, for example, like an English statement, and we want to be able to turn this into these algebraic expressions that we can then work with. And just like I said, to understand algebra, you need to understand arithmetic. After that, algebra is really the foundation of just about every form of mathematics that you do down the road. Almost everything, you're still using these tools of algebra to manipulate and to change equations and expressions. So algebra is really it's the backbone of any sort of higher mathematics, I would argue. Okay, so let's get going here. So in algebra, we often use letters to represent numbers. Okay, so we use now letters to represent numbers, and we're trying to introduce some generality. And you can use whatever letters you want. I've got a couple here listed. We've got X, Y, capital L, capital W, capital A, and these represent numerical quantities. So these letters are what are called variables. So when you hear someone talking about a variable, they're just talking about these letters used to represent these numerical quantities. So for example, I've got just a basic example here. Suppose we've got a rectangle. Now we could assign specific numbers to it, but again, maybe we want to work with it in a more general form. So instead of having specific numbers, well, I've got L listed for my length, and it's a rectangle, so right, it's going to be the same value of L on each side. And then we've got another value, the width, and again, that's going to be the same value on both the left side and the right side, again, because it's a rectangle. So now I've got this rectangle represented with these these variables, these more general quantities, capital L and capital W. And again, you could have used any letters you want. Oftentimes, I think it's a good practice. Oftentimes you will use letters that, sort of correspond to what you're working with. So again, for example, here where we're talking about length and width when we talk about rectangles. So why not use L and W? That to me seems to be a good reason. But again, you could have used X and Y or P and Q, or pick your two favorite letters. Okay, so let's talk about just some of our notation. We're going to talk about these fundamental operations of arithmetic. And when we talk about the fundamental operations, we're talking about addition, subtraction, multiplication, and division. So I think a lot of this will be relatively intuitive. So for example, when we write X plus Y, that simply means the sum of the quantity X and the quantity Y. Likewise, X minus Y simply means the difference of X and Y. Okay, so far so good. Next, let's talk about multiplication, or a product. And a lot of times, at least, when I was a kid, when we were multiplying numbers, we would have 3 times 5, and our multiplication symbol looked like a little, kind of like an X or a cross. And that's how we would write multiplication. 3 times 5 is 15. Well, when you do algebra, you're never ever going to see this symbol anymore. So when we talk about multiplication, when we write it in algebra, there's 3 different notations that we'll use. So instead of using the little X or the little cross, we'll do one of 3 things. We replace that with a little dot in the middle. So again, that means multiplication. Sometimes you'll just put those quantities in parentheses, and notice there's no dot between them, but it's understood that those are being multiplied. Likewise, at the very bottom there, we still just write xy. There's no parentheses on either one, but again, that means that those 2 values are being multiplied together. So all of these expressions indicate the product of x and y, or we can say x times y. Likewise, when we do division, at least when I did it in elementary school, right, we would write the little division sign, 20 divided by 4. But again, you'll almost never ever see this division sign in algebra. And to represent division, we just write we make it look like a fraction. So in this case, we have x in the numerator, we have y in the denominator, and that means that x is divided by y, or we say it's the quotient of x and y. So those are going to be our notations. So next I've got a bunch of examples, and what we're going to do is we're just going to try to write these expressions using the symbols that we just saw, using that notation. So there's quite a few, and of course, as always, if you want to, pause and practice these as I go through them, or, if you're just learning this and a little confused, feel free to watch. So, okay, so the first one, let me maybe change my color. Well, we can leave it the same color. So my first example, I've got w plus z. Well, if I want to write that, I would just have, w plus z. So easy enough. Number 2, m is increased by 4. Well, if I increase a quantity by 4, what am I doing to it? Well, you're adding 4 to that quantity. So I would have, in this case, m plus 4. That would say the same thing as m is increased by 4. So I'm kind of taking this English phrase here, and I'm converting it into this algebraic notation. So number 3, the product of 5 and c. So product, that has to do with multiplication. So we could just write either 5 and a little dot. If you peeked over at me, I would just write it as 5c. A lot of mathematicians tend to like the fewer symbols, the better. So if we don't need the dot, why even bother having it? Okay, so all of these operations that we're talking about, addition, subtraction, multiplication, division, they ultimately work on 2 quantities at a time. But we can still write these expressions with more variables than just 2 variables. So, for example, in number 4, we've got the product of 9, m, and n. So we're multiplying all of those together. So we could just write 9, m, n. And that simply says that 9 is being multiplied by m, which is being multiplied by n. And this is what I was saying a second ago, too, that, okay, we've got these 3 symbols here, right? We've got the number 9, and then we have 2 variables. If we were going to simplify these, for example, suppose I had just 3 numbers. We'll say 9 times 2 times 4. Multiplication acts on 2 numbers at a time. So what I would do, well, I would combine the 9 times 2. That would give me 18. And then I could take 18 times 4. So again, I'm just combining them pairwise, 2 at a time. And let's see, 18 times 4, that's going to give us 72. But again, these expressions can involve certainly more than just 2 variables. So number 5, the product of m and 3 more than m. Well, let's see. So I've got the product of m and something else. So again, we could write our dot if we want to. I'm going to omit it. And we're going to multiply that by 3 more than m. So let's see, 3 more than m, how would I write that? Well, I think I could write that as m plus 3. That would be 3 more than m, right? I start with m, and I add an additional 3 to it. So I've got m and 3 more than m. And now I would have to be careful, because if I just wrote it like as m plus 3, that would be incorrect, because it's saying the things that are being multiplied, it's saying I'm doing n times m and then adding 3. But I don't want that. I want m multiplied by that quantity m plus 3. So this is where we would have to be more careful, and this is where we would need a little set of parentheses. So m parentheses m plus 3. So now I'm taking the product of m and 3 more than m. So again, compare that to what I had here just a second ago as well, and convince yourself that those do in fact say something different. You could even pick a specific number for m, maybe let m equal 5, and do the arithmetic in each case, and you'll see that in fact you definitely do not get the same value. So we don't want this one for sure. These parentheses are going to be crucial. Okay, so the difference x minus y divided by 9. Okay, so I've got a difference, so I know there's going to be a fraction in there somewhere. Well, x minus y, there's x minus y. And it says that quantity is what's being divided by 9. And it wouldn't be incorrect to even put this in parentheses, but you don't have to have it in this case. It still says the same thing. Okay, twice the sum of a number and 6. Twice the sum of a number and 6. Let's call that number x. We don't know what it is. So the sum of a number and 6, well, that would be x plus 6. And it says we want to double that. We want to take twice that sum. So if we take twice something, well, we multiply by 2. So that would be the expression 2. Again, notice we have to have parentheses around the x plus 6. Okay, the product of 5 less than a number and 5 more than the same number. Okay, so maybe I'll call our number, our own unknown number, we'll call that n. Okay, so the product of 5 less than a number. So to take 5 less, I take whatever number it is and subtract 5 away from it. So that now takes care of, I've now got that expression there, 5 less than a number n. And we also want to take 5 more than the same number, and then we want to take the product of those two things. Well, 5 more than the same number, that would be n plus 5. But now we want to take the product of those two quantities. So again, I have to be careful. I want to put both of these in parentheses. Okay, so there's my product of 5 less than a number and 5 more than a number. Okay, so I think I've got a few more of these here, because you'll see these things all the time, so it's definitely worth doing a little extra practice. So the quotient when 7 less than a number is divided by 3. Well, again, let's call our number, let's just call it n. Okay, so quotient, that has to do with division, with our fraction. 7 less than a number, well, I take my number and subtract 7, and it says that is divided by 3. So that's very similar to our other example, number 6. Let's see, 4/3 times pi times the cube of the radius r. Okay, so we've got all this multiplication, so 4/3 times pi, and again, I can just stick those next to each other. It's understood that they're being multiplied. Again, you could put them in parentheses, 4/3, and you could put the pi in parentheses, or you could put the dot in between them. But again, typically, you'll just see it written in this more compact form. And then it says times the cube of the radius r. Well, recall that if we have the cube of some quantity, we take that value and we multiply it by itself 3 times. So this is now going to be the cube of r. I'm multiplying it 3 times. Now if we want to, using properties of exponents, 4/3 pi, and we'll definitely talk about this more, we could write this more compactly, this r times r times r, because what if you had to multiply something by itself 100 times, right? You don't want to write 100 r's. So what I'll do is I'll write r, and I make a little exponent up here to the 3rd power. And what this notation means is, it means I have this quantity, this variable r, multiplied by itself 3 times. That's what that notation means. So r times r times r, that's the same thing as r raised to the power of 3. And notice the only thing that's being raised to that power of 3 is the r. It's only the r. It's not the pi, and it's not the 4/3. That exponent only applies to that variable r. Okay, we'll just leave that there. Okay, I think we've got one more here. 1/2 the product of the height h and the sum of 2 unequal sides b1 and b2. Okay, so we've got a couple things here. I'm going to focus on the latter half here. I'm going to think about the product of the height h. Okay, so I'm doing the product. That's h times some stuff. And now it says I'm taking that and I'm multiplying it by the sum of 2 unequal sides b1 and b2. So this is where we have to take the sum. So there's little b1 plus b2. But again, if I wrote it like this, it says only the b1 is being multiplied by h. But I want h to be multiplied to the sum of both of those. So I would need to put the b1 plus b2 in parentheses. And lastly, I've got 1/2. So I could write this as 1/2. I could even write this. Okay, so that's one way to write it. Another way that we could write this that would be absolutely equivalent is we could have h b1 plus b2 all over 2. Those would be equivalent. They'll say the exact same thing. But I think in this case, we're more looking for this expression on the left. But again, if I had this on a quiz or a test and asked someone to do this, I would be 100% happy with either one of these results. I would say, perfect, you got it. Okay. Now, I keep using the word expression, and I didn't really define it, but let's look at this real quick. I've got fewer examples of these. So an expression is a meaningful collection of numbers, variables, and symbols of operation. Okay, well, to me, this sort of begs the question, what does it mean to be meaningful, right? We're doing a little hand waving here, and hopefully we can just point out a few examples about kind of what to look for and why things don't make sense. Okay, so let's pick out which of these are expressions and which are not. So in my first example, I've got 2w plus 4. Well, that says I'm going to take 2 and multiply that by the variable 4, and whatever I get, and then I would add 4 to that. This would be perfectly acceptable. So I would say, yes, this is an expression. Now, notice in my next example, I've got x, and then plus times plus 7. Well, these operations, again, you're combining two things. Well, what is this plus times plus? What does that mean to even do here? Am I doing x plus 7? Am I multiplying 7? And this is just bad notation. This just doesn't mean anything algebraically. So I would say no, this is not an expression. So a lot of times you can just pick out, like if you have a couple of these operations together, something's wrong. Okay. And again, that's vague. We'll talk about that a little bit as well. Number 3. So here it's the same thing. I've got 8 minus and then multiplication x. Well, what does that mean to do? Am I subtracting x? Am I taking 8 times x? What's that minus sign doing? I don't know. So again, this is just bad notation. It doesn't mean anything. So not an expression. Let's see, we've got a few more here. 4 is much like our very first, or excuse, not our first one. It's going to be like one of our later ones, I think, actually. I apologize. So in 4, it just says, hey, we've got x, and then we're going to add the variable y. So we've got x, we're going to add y to that, and then I'll subtract whatever value w has, and then I'll add on whatever value z has. So yes, that's an expression. That makes sense. That's something I could do. And a lot of times, again, you can think, like if I filled these in with numbers, would I know what to do? Like up here, like in number 2, if I'm just going to pick a number at random. Suppose I put 5 there, and I've got 5 plus times plus 7. Like, what do you do with that? I don't know. That's why it's, again, not an expression. And the same thing on this one. Maybe I'll just pick numbers 10 plus 4 minus 3 plus 2. Well, I could evaluate that using arithmetic. I would just, combine them 2 at a time, then subtract 3, and then add 2, and I would be in business. So yes, that would be an expression. The same thing for number 5. It says, okay, in this case, we're going to take our length plus our width. We would add those values together, and then we would simply multiply that by the number 8 at the end. So again, if I had numbers here, 8, and then I had to say 4 plus, 6, I would know what to do here. I would do 4 plus 6, that would give me 10, and then I would multiply that by 8 to get 80. So yes, this is an expression. Okay, now one thing you can immediately pick out to know when you don't have an expression is if you have an equal sign. So already I know that no, this is not an expression, but maybe I'll put in parentheses here, but it is an equation. And we will deal with equations all throughout algebra. We will be dealing with equations forever and ever and ever and ever in mathematics. So it is an equation, but it's not an expression because of that equal sign. Had we only looked at this part on the right side, suppose the A equals, suppose that wasn't there. If we only had the 8 multiplied by L plus W, which is exactly what we had right above, right? We had that right there. Then yes, it would be an expression at that point. But the way we had it written originally, because of that equal sign, it is not an expression. Okay, 7. Is this an expression? Well, yes, I think so. Because again, think about if you plugged in a number here, for x. Well, what would you do? And let's maybe, I'll just make like a little example. So 4 times, and this is what I was saying at the beginning too. Sometimes it's nice just to substitute variables with numbers to get a better feel for it. Well, in this case, I would do 4 minus, let's see, so that's 10 plus 5, which is 4 minus 15. And you can think if you had $4 in your bank account, but somehow, maybe when you get older, once you're there, when you can always spend too much money on your credit card and then you go in debt. So maybe you actually spent $15. So you had $4, but then you took away $15. Well, what happens in this case? Well, now you're left with negative $11. It says you got to go pay the credit card back $11. You're now officially in debt. But again, I could work with numbers in this case and do the arithmetic. So yes, this is an expression. And last but not least, number 8. Okay, in the bottom, like I kind of look at them individually. So x plus y, that's an expression. It just says add those two numbers together. And then it says after that, I could multiply that by 10. So the top part looks good to me. The numerator, that's all an expression. And then in the denominator, that looks good to me as well. It says you just take whatever w is, and you subtract 3 away from it. So I've got an expression in the top, and I've got an expression in the bottom. Well, as long as you have two expressions, if you're dividing them, yes, you still have an expression involved in that case. So, okay, just a few basics here. Again, we'll talk about equations and expressions all the time, working with expressions, especially when you end up with these word problems. I mean, you kind of learn the sort of the nuts and bolts of how to tackle problems, but in the real world, you often end up, with sort of these English statements or whatever language you may be speaking out there. And what you have to do is you have to take that and translate it into something mathematical. And then the idea is once we have these mathematical formula, these expressions, or in certain cases, we'll definitely be dealing again with equations, then there's all the rules on how to manipulate them to arrive at a solution or to get some information about the situation that you're studying in the first place. So again, being able to translate from words into mathematical symbols, a lot of times that's going to be a first step. And then it's going to be applying the rules of algebra to, again, deduce even more information about the situation that you're curious about.